welcome guys. Thank you for joining. This is our fifth webinar, Friday. Today is Friday already. 4 webinars passed and we are almost at the finish line. So probably all of you already know all of our rules, right? About Q&A and chat and other functionalities. So probably I don't have to repeat it all, but still, just maybe if we have any new guys on the call for whom this is the first session, I will briefly explain it one more time. So please use chat for all your comments, all your messages during the talk. And please use Q&A for questions to our speaker. He'll review it after presentation or maybe during the talk. But still, please send all of your questions there. If you have any questions to me, please send it to chat. I'm monitoring it and answering you all the time. So please, well, don't hesitate to do that. Those of you who participated yesterday and on Wednesday should have received an email with this morning. Well, for me, morning, but maybe for you, it was other time, but still, you should have received already materials from third and our fourth session. So it should be there in your emails. Check your mailboxes. And for the organizational part, this is all from my side. And now I would like to introduce you to our today's speaker, Ivan Stepnikov. Ivan is from Russia, as myself, so greetings from Russia today. Our marathon is truly international. Yeah, hi Ivan. And so I'm passing the floor to you. Please, let's start. Let's do that.
Hello, everyone. Today we're gonna talk about technical stacks. What are the right stack? What are the, I would say, legacy stack? And maybe just this session, a kind of technical overview of a kind of modern technical stack that is recommended to use for some application. It's more or less universal. And let's go on. Basically, first, I'd like to touch some well-known stacks. I guess all of them have some experience. All of you have some experience with the well-known technical stacks, and it's just, you know, just kind of historical retrospective of what was previously, and maybe not even previously, and what's done now. And I think a lot of people currently using these technical stacks. And first of them is LAMP, which is Linux, Apache, HTTP server, MySQL, and PHP. Could you please, for example, type something like plus sign to the chat who had some experience with this stack? Oh, I see a lot of people. This is great. Basically, I would say a lot of web applications were developed using this stack, and I think this stack is pretty good in the terms of barrier. I would say entrance barrier that have to be spent by a person to study this stack and to write some pretty nice applications on the web. But basically, this is one of the main advantages of this stack. So it's very well known. There are a lot of solutions I developed using this stack. It's easy to start. On the other hand, I would say this stack is not perfect on the high-loaded systems. At least from a point of scalability, I would say MySQL is not the best thing in the world. Also, I think it's in the model cloud infrastructure where the auto-scaling is a kind of crucial question. I would say this stack is not perfect as well. And also technologies are not the cutting edge frankly speaking. And which is why we need to go to the next slide. And on the next slide, I would mention a different stack, which is also, I would say, web-centric. And here the stack is mean, or like as alternative MERN or MERN, and which is MongoDB, Express.js, Angular, Node.js. Also possible React and Vue.js. I think these stacks are more or less modern, and for example, even such companies as PayPal or Netflix are currently using this stack partly. I would say this stack also shows pretty good performance in the case of document-oriented storage and in the case of document-oriented tasks. But I would say also there are a few disadvantages of this stack. First disadvantage is that this stack is very JavaScript or TypeScript oriented. I would say auto-scaling is also a big question, and I need analytical queries, I would say, is a thing that doesn't come out of the box, and you need to do some tricky things to run analytical queries against MongoDB. Okay. Sorry. The next thing I'd like to talk about is more or less universal and modern stack, which is our point of concentration. And the name of this stack is KOST, like Kubernetes, Operator, Spark, and TiDB. Let's consider this stack and go component by component. I think you're already, all of them are more or less familiar with the containerized applications. And I think this is the most typical approach in the software development. And Kubernetes, I think it's also a pretty well-known tool. It's not the only one, but it's like a technology standard, especially in the case of cloud services. For example, you can go to Amazon, you can go to Azure and get Kubernetes as a service. So basically, Kubernetes is a tool set for the didn't concentrate much, I would say, on this technology, but in general, what Kubernetes provides you with. First, service discovery and load balancing, storage orchestration, automatic rollouts and rollbacks, automatic bin packing, self-healing, circuit and configuration management. So basically, these are the benefits you can get from Kubernetes, but maybe it's a topic for a different session, but currently, as the overview, I think that's enough. Next technology in the stack is the operator. What operator is? Operator is a method of packing and deploying and managing Kubernetes application. And there are the following points can be automated by operators. Deploying application on demand and taking and restoring backups of application state, handling upgrades of the application code alongside related changes such as database schemas or extra configuration settings. Publishing a service to applications that don't support Kubernetes API to discard them. Simulating failures in all or parts of our clusters to test its resilience. Choosing a leader for distributed application without an internal member election process. So basically, these are the benefits of the operator. And let's dig in some details how it really works. Let's imagine you're trying to, I would say, work with your solution, which is a set of applications without operator. What it really means for you, you will have to prepare a separate configuration for each application. In this configuration, you have to set up a lot of parameters, such as, I don't know, access to the database, secret keys, environment configuration, maybe something like parameters of auto-scaling, etc. When you deploy, I would say it can be some of deployment, when you deploy it to the Kubernetes cluster, and finally you have a kind of corresponding pod in the Kubernetes cluster. As you know, Kubernetes cluster is controlled by a so-called control loop, and basically the main purpose of this control loop is to handle the cluster. And there are three basic activities in the control loop. First activity is to observe. Basically, that means control loop observe the cluster to understand what's going on there. Then div, that means in the borders of observation, control loop decides what's in the cluster is in the accordance, what should be there and what's not. And when we have some differences, then control loop acts. And basically act means to bring the cluster in the required state. For example, when you apply some configuration there, control loops observe some changes in the cluster configuration, then by control loop is detected what should be done in the cluster, and then control loop acts to do everything what's required in the cluster. And if you have a kind of really good big solution, I would say it's a problem to manage all these configuration files. Which is why there is a different approach, which called as operator. And what it really does. Basically, if you want to use operator, first you need to deploy operator lifecycle manager in the Kubernetes cluster. And the second thing, you have to deploy operator that consists of basically two parts: custom resource definition and controller. And then you deploy only one configuration file to the operator, and now it's up to operator decide what to do in the Kubernetes cluster, because it controls, I would say, some components itself. For example, you can specify some parameters in a single configuration file, and operator can use some default settings or even have some internal logics. How to deploy all necessary components, how to auto-scale it, where to get secrets, etc. So I think this is the main advantage of the operator, and at the moment there are a lot of operators that are currently available, and you can deploy it to your cluster, and also you can prepare your custom operators. Okay, let's move on. Next technology is pretty well known, and I think it originally came from the big data processing, and this is Spark. I would say it's kind of a large-scale analytical engine. And what main features you can get from the Spark? First, you can process the data, and you can process data in the batch manner or in the stream manner. Also, as long as internally Spark uses kind of direct acyclic graph, it's resilient and it's fault tolerant. Also, it gives you pretty good performance because all calculations in a normal situation are processed in memory. Also, Spark supports multiple programming languages and advanced analytics that can be done using different, I would say, APIs, internal approaches such as RDDs, such as data frames. We even can use SQL and some machine learning libraries are available, as well as graph algorithm libraries are also available for Spark. The key feature of the Spark is a distributed processing. That means if you run a task, it can be spread across the cluster and executed simultaneously in several cluster nodes. Another very important feature of Spark is that it's compatible with the Hadoop, or it's even part of the Hadoop. So it's applicable for the big data processing. And also, I would say in our Kubernetes cluster, there is a specific operator for the Spark, and you can use this operator when you need to roll out some Spark stuff. Okay. And next slide is about TiDB, and TiDB is a new SQL generation database, and the main feature of this database is a hybrid of transactional and analytical workload. That means it can be used as OLTP and like OLAP. Next feature is that it's, I would say, architectured for scale. That means it can be, again, scalable across the cluster. It supports two different approaches. It supports key value API as well as MySQL dialect. Then it allows to run Spark SQL directly on the storage level of the TiDB cluster. So that means if you have some Spark tasks that can be run directly in this database. Right. Another very important feature is a distributed query processing, and that means the query can be executed in several nodes of the cluster. Again, this is about distributed processing, which is a crucial thing in the modern world. Then, very important thing is configurable replication factor. I think I will return to this point a bit later. And the next point, I would say this is something pleasant, that there is an existing Kubernetes operator. Okay, let's go in some details about TiDB and how it works. I think I would start with the TiKV cluster, which is a storage for TiDB, and here you store the data in the key value form. Then the data can be accessed by two different approaches using key value API, which is the internal thing for TiDB. And the second option is to use distributed SQL API. then basically TiDB cluster performs these queries and gets the data for the applications. For example, in the case of MySQL dialect, there is a load balancer, and all queries come through the load balancer, and they come to some concrete nodes of the cluster, and again, they can be executed simultaneously in parallel. On the right-hand side, we got Spark processing. I think we already talked about Spark processing, and Spark clients can execute Spark tasks directly against TiDB storage. And all, I think all is managed by so-called PD cluster, which is placement driver cluster. And it's up to PD cluster to decide where to fire the query and where to get, I would say, proper regions. Then, how it's organized internally. There are raft groups and there are regions. Basically, the data is replicated several times, and a piece of the data is called as a region. For example, you've got region 1, which is replicated across store 2, store 3, and store 4. And as well as, for example, for region 2, you've got several nodes, and data is replicated several times in these nodes. And for example, for the region 3, you can look at the distribution, and region 3 is replicated in node 1, node 2, and node 3. And can anyone type in chat why it's so important to replicate data more than one time in different nodes? Well, basically, we got a task to process the query in parallel. And if you want to achieve it, that means the data should be available in different nodes. For example, if you want to start 3 parallel processes in 3 cluster nodes, you need to have the data in these 3 nodes. Otherwise, it's necessary to distribute the data across the network, which is pretty expensive operation. So that means if you increase replication factor, in theory, you can start more parallel streams for each query. On the other hand, it comes with a drawback that the data should be replicated across all these nodes. Okay. So next slide is just about kind of indicative performance estimates. Like, for example, if you've got MySQL and TiDB, MySQL in one node, deployed in one node, and TiDB is deployed in 3 nodes, you can see a difference in the query execution. And basically, you can see this difference because of parallel processing. If MySQL processes queries only in 1 node, TiDB processes query in 3 nodes. And that means you can finally pick up result much faster. Basically, this is especially important, for example, even if you don't have a large database, but there are a lot of users. It's necessary somehow to scale database. Example, one approach, kind of maybe custom replication, sharding, etc., whatever. But in the case of TiDB, you can simply increase the amount of hardware. And in theory, you can get a different level of performance. Okay. Now, oops, sorry. The next slide is about real project where this stack is used, and this is a kind of big data project with petabytes of information, with pretty complex processing, and with pretty sophisticated toolset. And what's more important in this slide? If you look at this, you can't see this KOST stack directly. But what we have here Hadoop, no KOST stack, some kind of specific data ingestion. Sure, you've got Kafka, you've got Audit Journal, you've got maybe Anaconda as an analytical toolkit. But, oh, okay, here you've got TiDB. And basically, as you see, information is delivered to TiDB from Hadoop. That means if Hadoop operates the call information, you can have data marts using TiDB. Okay, what next? I think we should also somewhere have Kubernetes. Also, we should somewhere have Operator and maybe Spark. Okay, Spark is hidden again in Hadoop, and I guess Hadoop in conjunction with TiDB can execute Spark tasks. So where is Kubernetes and Operator? And if you look here, here's a Istio, which is service mesh component, and usually is based on the Kubernetes, and it works on the top of Kubernetes and Operator in this project. So what does it mean? It means even for the real big data project with the petabytes of the data, I would say KOST stack takes significant part and solves some significant tasks for the project of this scale. And as a final slide, I will talk about why KOST is pretty good. And first, and I think it was stressed several times, that all components are cloud ready and scalable. And the stack is applicable for all solutions. For example, if we address LAMP stack or mean stack, this is all about web applications. And this stack more or less universal and can be used for different tasks. Then another important point, it can serve as a basis for service meshes. Some service meshes are, I don't know, like Istio, Linked, maybe Mesh, and so on. And all service meshes in reality work on the top of this stack. Then each component has at least one commercial vendor that is able to support it. And finally, KOST. I think KOST is also a pretty important point, and everything is open source. That means you can avoid some license costs. Okay, I think this is in general all about KOST stack, and now I think it's time for questions and answers. So do we have any questions to ask?
Yes, we do have one in the Q&A. It just appeared just now. I can read it if you want. Tell me, do you make a separate Kubernetes instance for each client's project you work with, or is it one instance that you connect to multiple projects?
Thank you for this question. I think it's pretty good and important. And the answer, I would say there is no a concrete answer to this question, and it depends on the task, and it depends on the client. Also, it depends on the client's needs, as well as it's all about project environment. Sometimes, from the point of I would say resource usage is better. I would say it's better to have only one cluster where you can auto scale all necessary services, and you can you can scale it out, you can scale it in, and as a result you can, I would say, save some computer resources. On the other hand, sometimes it comes with organizational restrictions, like, for example, I'm as a project owner, I don't want other projects to use my cluster. And also it's possible to have some security restrictions, like, you got different data assets, and different data assets as well as different services have different security sensitivity, and due to this point, it's necessary to prepare different clusters, just not to mix all the data together. For example, in my experience, it was a case like it was one project, it was kind of single solution, but it was necessary to have two different Kubernetes cluster, one in the demilitarized zone, one in the internal network. Okay.
Okay, should we move to the next question?
Okay, what's different? Yeah. Kubernetes and Docker. And I can say that Docker is not avoidable, and you got Docker container, and basically in the modern world, what I think works the Docker containers, but as soon as you've got Docker container, somebody or something has to take care about this container. Somebody or something has to check the state of this container. Somebody should be able to, for example, auto-scale this container across different computation resources. For example, you can have only one instance of the container, but when load grows up, you need to start some more instances of this container. So what I'm talking about, there should be a solution that orchestrates, I would say, a variety of your Docker containers. And this solution is Kubernetes. Okay.
There is a question in chat. The shown architecture of KOST is based on a real commercial project. Is that right?
Yes.
Good answer. Okay, the next one. Can one use some of the mean technologies like Angular into the KOST framework?
Yes, yes, sure. It doesn't, I would say, it doesn't contradict the KOST framework at all, because the KOST framework, the main purpose of the KOST framework is to capture the basis for all possible applications and all possible technology. For example, if you want to use Angular or Node.js, or MongoDB, it's not a problem. It can work with within the KOST stack.
Okay, the next question, I will take one from chat. If you mostly need a database, would you choose TiDB singly instead of MySQL or PostgreSQL? What disadvantages does TiDB have?
Okay, TiDB, disadvantages. Main disadvantage, sure, you get some drawbacks. For example, let's imagine you got one asset author data, and there are two different APIs for the data, which is key value API and SQL API. And if you, in the case, if you decide to use both of the APIs for the same data set, it will lead you to some problems. Basically, it makes some problems with the TiDB, and basically you will have to restore, as a matter of fact, you will have to restore the data in TiDB. It's the first disadvantage. So basically for one data set, you have to choose the approach. Otherwise, you come into the trouble. I think right now PinCap is working on this problem, but it's still existing. Another problem, or another maybe disadvantage, like if you compare insert speed of, I would say, vanilla MySQL and TiDB, in the second case it will be slightly slower, because in the second case the data should be replicated across different nodes of the cluster.
Okay.
I think this is enough. And about usage, I would say TiDB is not a problem at all. You know, if you've got Kubernetes cluster, you can, I would say, roll out this database just by typing one command line. On the other hand, if I would try to schedule future performance. And if, I don't know, it's a simple project and I don't expect millions of users, I would choose just vanilla MySQL rather than TiDB.
Concerning the project, there is a real good question. How many years took you to develop such architecture and implement it to the commercially successful? So how many years did you spend developing this architecture?
Developing architecture, several months. Implementation is a different, I would say, it's a different question, and it's still in the progress.
Questions are coming. I can read them just one by one, or maybe you'd like to pick like the most interesting.
Just one by one. I think.
Okay.
We got enough time.
Yeah, we have enough time. Okay. Is Kubernetes used for creating business process management software?
It can be used. It can be used. On the other hand, business process management software, I would say it's kind of more applied thing than Kubernetes, because Kubernetes just in the comparison to business process management is just more low-level thing, and it allows you to, for example, to operate your solutions. But it's not, you know, a business process management directly.
Okay. what is the important difference between SQL and TiDB?
I would say TiDB is still SQL, but with some additional features and with some restrictions. The main nature is restriction that we want to add incredible parallelism, and due to this parallelism, we got something that we have to care about.
Mm-hmm. Why is TiDB faster than MySQL? Is it because of parallelism?
Exactly. The main idea is, for example, if you execute a query in MySQL database, it's executed in, normally it's executed in one node only. But in the case of TiDB, this query can be executed in several nodes simultaneously. So then you execute it in parallel, pick up result, and drop result to the user.
Mm-hmm. How complex would it be to migrate from other, let's say, legacy stacks to the proposed?
It's not, well, basically it's a question to the staff who cares about the migration. In theory, not a big deal. For example, you get lump stack, it's the first step, not a problem, to put all components in the container and pass it to the under Kubernetes and operator control. I would say it can be done just in several weeks. On the other hand, if you want some kind of complex technology migration, like you, for example, you don't want PHP and you want, I don't know, for example, Node.js instead of PHP, then it's a different task and it's pretty different time it takes to migrate everything to different technologies.
Next question about Node.js. Do you think Node.js is very good in microservices?
Okay, it's a good question. Thank you for this question. And what I want to say is that microservices do not come alone. And right now there is a set of patterns of the distributed microservices management. For example, you have such pattern as load balancer. You got pattern service discovery. You got a pattern like circuit breaker. Also, you got pattern service configuration. Maybe something else. And in this, I would say in this projection, Node.js is not, I would say, very aligned with all this pattern because they, I would say, Node.js is pretty lightweight thing. And if you want to use some service mesh, basically, you can do it even with Node.js, but on the enterprise level, I would say you would need like kind more sophisticated solution. But this is just a personal opinion. Maybe you and I don't right.
Another question, well, quite a long one. So this is just a scheme for the set of the KOST tools. And in the different projects, we can remove some of these components or blocks. For example, the previous project on sports events, well, this project was yesterday presented by Artyom Butry. So this project uses similar structure with some components missing or replaced. Change me if I got something wrong. So the question is like, is it like a scheme to be implemented and we can remove something and, you know, pick up blocks that we want to?
I think it's a basis. I think it's a basis for the applications, for the solutions. And I think basically you've got Kubernetes, you've got operator, and you've got Spark. I think first two components can serve as a basis for everything, but second two components is not so obligatory, I think. And it may be just a matter of taste what you want to use. For example, if you don't need TiDB, you can avoid using it. If you don't have some kind of machine learning, distributed machine learning, or you don't have some data analytics, and then probably Spark is not your case as well.
Okay, can I use MySQL, Java, and OpenShift for web and soft development? Or I need to make a switch with TiDB?
I think we already partly answered this question. And you can, TiDB is not the obligation. And if in the terms of performance and in the terms of query simultaneous execution, you're okay with MySQL, you can live with a MySQL. But if you need a scalable database, probably MySQL is not your case. And sure, you can use all these technologies together with OpenShift. And I would say OpenShift includes at least Kubernetes, etc.
For better performance, is partitioning supported by TiDB?
I think partitioning is
I'm sorry, difficult
the main
word.
feature of all databases, but this is not for what we love TiDB. Again, we love TiDB, that one region can be replicated across different cluster nodes. And due to this feature, you can execute query in parallel. That means you even may avoid some partitioning if you have enough computation resources.
Another question about TiDB. Is it difficult to move from MySQL or any relation DB to TiDB? Does TiDB have any migration tool?
There are some migration tools, and also it depends on how you using your MySQL database. I would say if you don't really have some kind of storage procedure stuff, it shouldn't be a great problem. But sure, you will have to test your application properly after the migration process.
Can we suppose that KOST framework can be related to microservice approach?
Again, it's a good question, and I would say just like when you're talking about microservices approach is the architecture style, and sure, this style can be implemented within KOST framework. On the other hand, for example, you can say something like container is a microservice, and what is done by, I would say, and there are kind of interfaces, there are some kind of isolated functionality, etc. Yes. On the other hand, for example, it's possible to create containers of a different style, and you can isolate some project when you have to deal with a kind of monolithic containers that I would say aggregate a lot of different components. Then sure, with a kind of technology stack approach is not microservice related, but you've got a working application in the end.
That's a good result. What security can be implemented with Kubernetes?
I think, okay, I think it's a usual question about Kubernetes, and I think we shouldn't or we wouldn't cover this topic in this session because it's a kind of huge separate area, and I think maybe Yulia, maybe it's a question to you. We can schedule a separate session for the Kubernetes security.
Well, definitely. Yeah, let's discuss it. But I believe yes, we can do a separate session. Maybe not an inside marathon, but like a separate LTS webinar on this topic. Yeah. Yes, for sure. I'm collecting requests, guys, so you can send me your what topics you would like to be covered from our side in our next events. So last two questions. Can you explain how the replication of storage has been done? I'm not sure what done between regions again.
Okay, I think you can go to one of the previous slides. Okay, we got a kind of abstraction, which is a data region. And data region, one region, for example, you got region 1, and it's drawn as blue, and it contains exactly the same data. When in the configuration, you can configure a replication factor. Replication factor means how many, I would say, instances of the data you're going to have in the cluster, and how many times the region will be replicated. That means if you have a replication factor equals to 3, you will have each region replicated across the cluster 3 times. That means the region will exist 3 times in different cluster nodes. That means, for example, region 1 exists in node 2, node 3, and node 4. And for example, region 5 exists in node 1, node 3, and node 4. But each region exists 3 times. And none of regions exist, for example, several times in one node. So that means regions are spread across all the cluster. Okay?
Okay. So the final question, please clarify how the service discovery and load balancing work under Kubernetes.
I think it's a separate it's a separate topic, but briefly, first thing, you can use load balancing from the service mesh, and usually it's more typical approach at the moment. And in the terms of Kubernetes, usually you can use cluster IPs, or previously they were called like virtual IPs, and basing of some balancing proxy, Kubernetes is able to direct queries to different replicas. But
Okay.
again, Yulia, I think it's another topic for the discussion.
You know, I wrote it down. I wrote everything. Yeah, that's really cool that, you know, we touched some important topics that we can consider for our future sessions. This is very, very helpful for me, first of all. So we have only 3 minutes left. So
okay, I think there is another good question, and
okay,
thank you, Marco, for this question. And question about alternative to TiDB. About Postgres. There are something like Green Plum solutions or CyTOS for Postgres. I think they're kind of distributed databases, but the main feature which is different from TiDB is either CyTOS or Green Plum uses conception that's called share nothing. And that means one data can't appear in the several nodes or can be stored in in different nodes several times. So if you've got a data block, it's stored only in one cluster node. But on the other hand, it's possible to have a standby cluster, but it doesn't change the situation dramatically. Basically, if you need to process a query, you need to pick up the data using network from all nodes and then do something in the data. Which is why I would say approaches are not the same. And if I compare, I don't know, for example, Green Plum and TiDB, and if I can simply increase amount of hardware for TiDB and get better performance, if I want to do the same for Green Plum, I have to perform some incredible manipulations. I have to redistribute the data, etc.
Marco wrote this. Thank you to you in the chat. Thank you so much. So this was the final question for today because we have only 1 minute left. So I'm launching our regular poll. Ivan, could you please go to again to the Q&A slide so people could notice the magic word for today? Probably you could notice it yeah, during our Q&A, but still the word is technical. And tomorrow, those of you, those heroes who will connect tomorrow will discuss the very hot topic for IT in IT today, which is digital twins. It will be presented by our IoT solutions architect, Andrei Podnozov, and he will be talking from Seattle. So our final speaker is from the US. We covered like half of the world. So yes, I just checking your comments in the chat. Yes, Ivan, thank you for the really awesome presentation. I can see that questions was really, you know, meaningful. And yes, question from Mohammed, will it be tomorrow, Saturday? Really? Yes, it will be tomorrow, Saturday, absolutely. We'll do that. So if you could connect, it would be really great.
Yeah,
well, if not,
pure reporter.
You know, I can say that when we were preparing this marathon, we received 6 awesome topics and we couldn't exclude any of them. So we decided just to try, because now everybody, almost everybody in the world is under lockdown. So why not to try to do a presentation on Saturday? Why not? And we picked up really well, hot and, well, maybe generic, but really hot topic, which is digital twins, because I believe that, well, everyone wants to know how they're used now, because it's really new, new thing in the world, this very recent technology. So we'll talk about that tomorrow, guys. Thank you so much for being with us today. Have a good morning, day, or evening, whatever. Thank you for your time, and see you tomorrow, guys. Bye-bye. Have a good one.
Goodbye.